Really, in essence, in the real world, it simply means proportional. If you want to see what direct variation looks like, the book shows it, or math people show it like this, where y, equals k. I always go wrong with that part. Can I do that again? I want to do over. X. Y equals, that doesn't even look like a K. How come it doesn't look like a K?
Because your line, yeah, that was more like a K.
I need it to look more like
You gotta do the equal sign,
Yeah,
or
you have to
bubble
do the
letters.
equal sign above the letters.
You gotta like curve the bottom line.
There you go.
Yeah,
Yes.
Fabulous. Yes.
direct variation, again, is nothing more than proportional, which if you remember, for something to be proportional, it had to be two things. When you graphed it, it had to go through the origin, and it had to have the same constant of variation, which means this, okay? Well, which, by the way, this is. The letter K stands for the constant of variation. Okay, it's, if you're doing it in the book, I guess the best way to do it is like the book does. This is the equation, the direct variation equation.
The algorithm.
No, we're not, it's not a way of doing anything yet. If you're looking at what direct variation looks like on a graph, you know, an equation that would be direct variation would be like, let's say you get a job for $8 an hour, or if you go to Chicago where it's $15 an hour, but let's go here in Yorkville. Y, the amount of money you get paid, is 8 times how many hours you work. Okay, that is direct variation because when you put numbers in for X, if you work 0 hours, you get paid 0. That's a big one because that means it goes through the origin when you graph it. If you work 1 hour, you get $8. If you work 6 hours, you get $48. And it's always your constant of variation is what you multiply X by every time to get Y.
What if you do 2 hours equals 16? Or you just like
Yes,
figure
I do just, I don't mean 2 would equal 16 or whatever. You know, when you graphed it, it goes through the origin, you know, 1 hour, $8, 6 hours, 2 hours, 16, whatever. It's kind of that thing. You wouldn't have a negative because you couldn't work negative hours and have to owe somebody something. It just doesn't work that way. And then they also give you this. You know something's direct variation if they say simply this: Y varies directly with X. That's kind of the words that you'd say with that. And really all it means is one goes up, the other goes up. Now note, this could not be direct variation if you had Y equals 3X plus 2. Why can that not be direct variation?
because it's slope intersects.
It's not going
It won't go through the origin ever because if the y-intercept is 2.
plus 2.
Okay, so it
Oh,
can
and
only, it can only have a that.
What if it's because then it can equal 0, because then 0 is 0.
Yes, unless it's plus 0, thank you. For that.
Plus negative 0.
So a question they ask is this:
Plus negative.
is this direct
Oh, no.
variation? And they will give you such as this. 2, negative 14, 5, negative 35, 2, negative 14, 5, negative 35, and negative 3, 21. I believe they would ask you for the slope if they wanted the slope. In order to find out if these points represent direct variation, you just simply need to figure out if you can see what is the constant of variation. Or just do this. How do you go from 2 to negative 14? Multiply by negative 7. That would mean for this to be direct variation, you would have to multiply it every time by negative 7, and if it doesn't work, then it's not direct variation. If it doesn't have a constant of variation, negative 7 times this gives you negative 14, negative 7 times that gives you negative 35, negative 7 times that gives you 21. So absolutely this, yes, is direct variation. How do I know that goes through the origin? Because if I put 0 in it and multiply 0 by times negative 7, I'm going to get 0. If you would be so.
I get 7.
Let's do another one.
Let's just go with that.
Now we gotta do one of these.
Wait,
We don't have to.
wait, this.
So here, let's do something from the book. Write, I'll get your question in just a second. Write an equation for direct variation that includes this point. An equation for direct variation that includes. What has happened? Something my computer doesn't quite. The point. Let's say 5, 30.
Okay.
Now we already did the direct variation equation, which is simply y equals kx. You just need to figure out from this what the letter k is. And that should be relatively easy because to find out what k is, you just say, oh, what do I multiply 5 by to get 30?
6.
So my equation is y equals 6x. Now, let me throw this at you. What if, let's do a different point, what if it was 16, 8? Is that direct variation or not?
No.
Depends on.
No.
No.
And you still.
No.
No, it would be.
Yes, it is.
Who says yes?
No, it's not.
So the question is, you can't multiply 16 by anything to get 8?
Yeah, you
Yeah.
can.
One
I'll
half.
point.
So where's the question here? The equation is y equals 1/2 k. Yes, it
Or one
is.
half x.
I'm sorry. Yes, it is direct variation. As long as it is multiplication.
Come on, say no.
Really, children, if you are just given 1 point,
You
you
can figure out the
always could write a direct variation equation, even if it was 5, 6. What would the direct variation equation be for if the point was 5, 6?
1,6.
Well, you'd have to ask yourself, and this is what I would do, what times 5? 5 times what number gives me 6?
5 and 1.
Divide by 5, divide by 5, 6/5, or 1 1/5, thank you.
Oh.
But you'd write it out as y equals 6/5 x. Now, if you're given 2 points, it doesn't have to be direct variation, but given 1 point, you could always come up with some sort of a factor there. And then last one right here. Write this down. The number of boys in the class varies directly with the number of girls. varies directly with the number of girls. One class has 6 girls and 18 boys. One class has 6 girls and 18 boys. It's only writing half the letters, so. How many boys will be in a class with 8 girls?
Wait, 12 boys, right?
18.
Oh.
How many boys in a class with 8 girls? Now, a couple ways you could figure this out. Well, you could do it as a ratio, but since we're talking direct variation, where y equals k times x, the number of boys varies directly with the number of girls. So boys equals some constant of variation times girls. You could say, okay, what do I do times the girls to get to the boys? Multiply by what?
3.
So my constant of variation is 3, so if I know any amount of girls, I can always figure out the boys because it's just multiplied by 3. Boys equals 3 times 8, which is 24. But it is also, did Holly say, did you say that? It is also proportional or ratio-ish. You could still, you can do it as a ratio box, you will still get the same sort of answer because it is direct variation if you're comparing boys to girls. If there are 18 boys and 6 girls, if there's 8 girls, how many boys are there? It could still be done that way. You know, cross canceling, whatever, however way you want to do it. But since we were talking about directly proportional or direct variation, that would be the. Just remember, y equals kx. That is good.
Wait, so is the answer y equals 24x?
No, if they ask you for the equation,
Oh,
it wouldn't even
it's
be
just
that.
24.
y equals
y
3x would
Over
be the
x
equation.
equals k. That's what I have.
Y over x equals k. I don't know why you have this,
I don't know why.
but is that direct variation? Yes, because if you solve for y, what do you have to do? Multiply both sides by,
X.
multiply this by x, multiply this by x, it's the same thing. Y equals kx. Now you can't have this though, this is not direct variation, y equals k divided by x. Can't do that. K cannot be the dividing part of it. Got that? It could be this, it could be that, it can be all sorts of things. We're stopping it. Alright. Oh no.